Hey guys, so I'm Uribe. I flew in from Chile,
Yeah, and I'm JP. I'm from Brazil.
and we're representing Cornershop at Uber. So we're here to talk about using new tech while supporting legacy code. So who's going to benefit from this talk? Well, just to give you guys a little bit of context of where we came from, we started as a small startup in Chile in 2015, and we experienced a very steady growth over the couple years that went after. So we started in Chile, then expanded to Colombia, Brazil, Peru, Mexico, and then we ended up going into the US and Canada as well. So now we're across the American continents. And now, after the pandemic, we experienced an explosion of growth, which led to an explosion of features as well. And this meant we had to work with, some code that we started as a startup, probably a little bit messy, crunchy, and we had to work with that to build on top and scale really quickly to be able to support our millions of users. So we think that even though this was a very specific case for us, the lessons that we had apply for everyone. So they can apply for junior developers who are looking into more of the architectural approach to adding new frameworks. They apply for principal engineers who maybe want to motivate their teams and want to have an idea of how we got to push the product team and the business teams to allow us to use these APIs. And just in general, if you want to vibe with the struggle of dealing with this sort of issue, the balance of product and development and dealing with bugs, well, you're in the right place. So as we know, there are new API updates every year. A lot of them come from Apple, of course, with extensions to UIKit, newer frameworks like SwiftUI, Combine, the addition of async and await. And there are also third-party frameworks. They always add on top as well new features or new abilities in managing data or processes, depending on what the frameworks do. But there's a dream and there's a reality, especially when you're working at scale, because we have these new APIs, and for us as developers, they're shiny new toys. But for the product team, they're more like risks, right? So we need to make sure that before we play with these APIs and actually add them into production, that we have some sort of approach to them. So we want to make sure, of course, that we have the product team's approval, because adding a new framework might affect the roadmap, the timeline of a product. We also might need a deprecation strategy. So maybe a framework doesn't apply for iOS 12, or maybe there are differences in how the framework behaves depending on the iOS, of course. So we want to plan for that. And then we want to determine opportunities to actually build using these frameworks. This might be a little bit difficult because you would think a new framework a new feature would be a good candidate for this, but you also have to be careful with what the feature is and how sensitive it is for the company, the team, the users. And so it's important to have a proper execution strategy, but this is a bit hard. So why is that? Because, well, for one, rewriting entire modules to be able to incorporate these APIs is unsustainable. We can't just take a whole feature or a whole flow of the app and convert it to Swift. That's impractical. And new features are also sensitive and usually time sensitive. So like I said, we can't just assume that we can add a new framework just because it's a new feature. And a new feature also entails adding, it usually means that we're adding something on top of existing features, right? That's the usual use case. You have this existing app, and maybe you want to add a new setting in the account or a new type of payment method. And so you're going to have to connect these sort of extensions or modules with the existing features. And so any new API used will probably have to at least not directly interact, but indirectly interact with these existing features in mind. So just before we continue with some examples of our approach with this intersection of new APIs and legacy code, we want to set the mindset. So determining features where it's important to use these new APIs is a very important part of the strategy. You know, you want to make sure that adding these APIs makes sense because it's advantageous. It benefits the feature, or it benefits the developers in implementing the feature. You will probably have to use this sort of reasoning to convince the product team. And it's always useful to tell them that, you know, this will also improve the user experience. And the other part is, you know, when you look at using these new APIs, you want to make sure you contain the integration of them and to minimize the refactoring. So you want to, you know, usually apply solid principles where you contain the API in a specific layer, hopefully a layer that can be modularized and reused. But this is not always the case. So you have to think about the use case and how the API might travel across the app. But this also means that you might not want to fight against the legacy code. And we'll talk a little bit more about that. So now we'll go over an example of our intersection between legacy code and new frameworks.
Of course, thanks, Ever. Well, good morning, everyone. I'm João Pedro, but everyone calls me JP to avoid all the Joaos that you may hear. And I've been working in Cornershop for almost 2 years. I was the iOS developer responsible for creating this awesome multi-images experience. So integrating an Apple-inspired UX into one of our most used views. As I said, it was inspired by one of the Apple's app, the iMessage. And you can see on the left, on the right, sorry, this is like a GIF with some of our images that is exactly the iMessage app. And it looks like a deck of cards, right? That was designed, wanted. And this is the mock-up that we received. You can see it's pretty similar, and that's our product page. So the context. The thing was that we had a very small time frame to deliver this. It was a matter of 1 month. And this was because it was a contractual agreement with one of our partners in the US. So it was a small time frame and super urgent. And design, for some reason, decided to get creative, even with all of that in mind. So let's do one thing. I want everyone to stand up. Like, everyone, please. I know it's early, but that would be good.
Stretching.
Yeah, stretching, exactly. And I know some of you are still in hangover, right? Because of tomorrow? Yeah. So you can sit down if you never worked with SwiftUI before.
Nice.
Like now, just sit down. Oh, wow, just a few people.
Pretty good.
Okay, interesting. Now, just keep standing up if you don't have to deal with, keep standing up if you have to deal with legacy code on a daily basis, like a node code in your base. Everyone, right? Almost.
Lucky
okay.
few, lucky few.
Lucky few, yeah. Now, keep standing up if you ever had to communicate between SwiftUI and this old, terrible legacy code. Okay. Okay, for those of you that had this awesome experience of having to communicate between them, keep standing up if you liked it. Okay, for the 3 masochists that we have in the middle, I mean, you can sit down. Yeah, so we decided to use SwiftUI to create this animation because we thought that complex animations would be made easy, and that was a reality. I created like a POC, like a proof of concept app, using SwiftUI, and I mean, the app was new, a whole new project. I could use the live preview, it was awesome, and the design team just loved how it looked. So I had the design team on my side on using SwiftUI. Then we thought it would be easy to integrate this with UIKit's ObjC controller that we had. And I mean, the most important part is that we are very enthusiastic about using new technologies, and we saw that as an opportunity to use SwiftUI in a big project. But I mean, that was what us as engineers thought. You know, we are super excited and all, but leadership doesn't always feel this way. So we had to sell that to them. And the first thing we said was that the time loss with dealing with a lot of unexpected behaviors and some limitations that SwiftUI still have would be compensated by how easy it would be to create all those animations, as I showed in my POC, you know? And learning SwiftUI would be an investment to the iOS team, because we always wanted like to have a Swift UI champion in the team to be able to like give some talks to the team and be like a point in common for those who have questions about it to ask, you know? And that happened. So they accepted the challenge, and I mean, the first one we had to deal with was to achieve the exact same UX and UI experience they wanted. So this is the deck of cards effects, and I'll show you how easy it was to achieve in SwiftUI. I'll not enter like in much details about how SwiftUI works, but basically we have here like the body and a Z stack, and inside of it a for each that iterates through all the cards from our model. Inside we have a Z stack and another image instance, and this image is the one that will receive all the effects. I mean, I'm ignoring here like the rounded corner, you know, the shadow and some other stuff, but these are the ones that will make this look like a deck of cards. So all the images are like one on top of the other here. So here we are adding offset, then brightness that gives a depth feeling, z-index, scale, and rotation. And you know, with those simple view modifiers, like 5, we managed to create this awesome view, this deck of cards in SwiftUI. Animations. Yeah, here's like the part that I like the most. We could use this mesh geometry effect that is one of the coolest view modifier that SwiftUI have, in my opinion. And in order to do this, we do the following. You can see on top that we have exactly the same thing you looked at the previous slide, but we have an if statement that checks for a state variable, like a Boolean. And on the bottom, we have exactly the same structure, but here I'm hiding like the differences that are like the offset, corner radius is different, the position, and the frame, right? On both of them, we had an on-tap gesture modifier that toggles the full screen, and we have a match geometry effect that receives an identifier, and this identifier needs to be the same for the two cards that are like transitioning between them, and a namespace that I won't enter in much detail, but basically needs to be the same in the views that you are working on. It's just a namespace variable with no content. And I mean, if you're working with this in the near future, or if you are struggling with any bugs related, please make sure that you put frame after match geometry effect. And I mean, those things are not super clear to find in documentation, and we'll talk about it later, how hard it is to deal with those mini, tiny bugs that are super hard to find. But this is how it looks. Now, I talked about the on-tap gesture that is where we managed to toggle between full screen and non-full screen mode. But then we have to deal with a drag gesture, right? You can see here the percentage is changing. This is basically the percentage of how much the first image is translated, or to the right or to the left. And to use this information, we need to add a drag gesture. And I mean, drag gesture, we don't have like a non-drag gesture like we have in the tap. So we need to create a gesture and pass to it a drag gesture. And then it receives a non-changed and a non-ended. And again, make sure you put gesture after tap gesture, because otherwise it won't work. And we can call like our model in this case and pass the drag translation in the unchanged. And with this translation, we can calculate what's the percentage of how much the first image is translated to the right or to the left. And our model, that is the one responsible for giving all the other cards its effects, can deliver like an effect, but considering the percentage. So you can see that when I translate the first one, all the other ones comes together, like the scale changes, the rotation, all of it depends on the percentage too. Yeah, other challenges. Integrating this with one of the oldest view controllers of our code base in Objective-C was definitely one of them. This is the view, like the product view that you can see is the product detail. And it was from 2015, and it was terrible, like a bunch of lines of code, a huge view controller. We didn't have time like to completely refactor it, obviously. We had like a month. So what we did was to inject SwiftUI on this view using a builder. And how does it work? It's basically a class that needs to be available to Objective-C in this case. And this class receives a delegate that I'll talk about later, and a view model that is used in this create controller method to create the controller instance. And how does it do it? It just creates like a custom view instance, passing the view model that it received and the delegate. And then it creates a hosting controller, passing this custom view that we just created. And it delivers this hosting view controller as a UI view controller. Then, in Objective-C, and this is very similar to what we have in our app, we just configure the multi-images view by creating an instance of the builder and calling the method createController from it. And then we have a controller instance, and we can add its view as a subview in the presenting view. Configure its layout, and very importantly, we need to call the did move to parent view controller on the controller that we just created. Then we just save the instance, and in order to remove it later, if calling this method again, because we don't recreate this product view all the time. If we switch products, we'll just fetch the images again and recreate the component. So, why do we have a delegate? That was the way we found to easily send back actions to UIKit. The actions was pretty simple, like triggering an analytics event, or keeping track of the image index, or, and this is the sad part, opening full screen mode. Like I showed you before, that awesome like mesh geometry effect animation that we managed to create in SwiftUI in my POC, and it was working awesomely, but we couldn't use it because we needed some behaviors that weren't possible, and I'll show you guys later why. But this is basically just a simple protocol, and our SwiftUI view receives it in its initializer and calls it, for example, in the onTap. So it's simple. Now, how do we do the opposite? Like in this example, we had our full screen mode in like a page view controller in UIKit. How do we manage to transition the SwiftUI view from the UIKit? We basically just have a method in our builder that accesses the reference of the created like controller, and then it accesses its root view. And it can call a method like transition method. The Objective-C view that contains instance of the builder, just call the builder's method, and that's it. Like Objective-C view doesn't need to communicate directly with our SwiftUI view. Only the builder knows what it does. Some limitations. Yeah, now talking about the full screen drama. That was probably one of the biggest ones we had, right? I showed you before that OnTap and drag weren't working correctly together. I mean, only in a specific order. Well, pinch to zoom and drag completely doesn't work. Like, it's super hard. And what is possible to do is to create, I don't know if you guys already worked with it, but a UI view representable, I think that's the name. And that's basically a way of using UIKit code inside SwiftUI. But I mean, it wouldn't make a lot of sense since we wanted this feature to be in SwiftUI. Like, why deprecate our UIKit view if we're using UIKit anyway, you know? But even like so, we did, and it wasn't working correctly. It was super limited, and it still conflict a little bit with the drag gesture. So we decided to fall back to UIKit since our design really wanted the same full screen behavior they had in production. But we needed to tell them that, right? Tell them that by doing so, we wouldn't have this awesome mesh geometry effect of opening and closing. You can see the animation where they come all together when closing it. And in reality, we're just animating the top card because that was the behavior we already had. But this behavior that already existed, it was limited because we had like a component that would receive a UI image view and would translate, like drag it into the middle of the screen and scale it, and would do everything we wanted, like the effect was done. But it needed to be a UI image view, and we didn't have time like to completely refactor it and change it. And it was very old, so hard to change. What we did was to work around this by creating just a temporary UI image view on top of SwiftUI and hiding the first image in the SwiftUI deck of cards. So that was it, and that was the quick solution. We had like days to deliver. Another workaround we had was the updater. Again, I will not enter in much details about SwiftUI here, but in order to update a SwiftUI view from like UIKit or from another view, one of the possibilities is to have an observable object class instance inside SwiftUI, and then to have at least one published property in this observable object class. Once you update this published property, the whole class will be updated. So what we did, what we thought on doing was to grab our model, right, the one responsible for handling all the effects and all that stuff, and just like making the index of the current card a published variable, and making it a class and making it an observable object. But it was a struct, and when we did this, it became super glitchy and heavy. And that's because an observable object needs to be clean. It needs to have like only a few responsibilities because it won't work perfectly. It can mess the animation a little bit. So what we did was to leave that as a struct and create a separated updater class. That is just an observable object that contains only one published variable. We just toggle it when we need to update, for example, the card index from outside of it, from Objective-C. And this is the final result. Like, we were super happy with it. You can see that in the end, we managed to use new other types of ratios and all. And I mean, that was what went to production. And you guys can see in the app if you want. So let's get back to Ever, and he'll talk about other examples of how we use new APIs in legacy code.
Thanks, JP. So another situation where you had to find this sort of intersection between legacy code and a modern framework was supporting a local card. So as many other apps have had this situation, Cornershop did not support an experience without an account. So what this meant was the user had to sign up, give their data, their email address, their name, in order to be actually be able to use the app. So as Apple now suggests, of course, in the human interface guidelines, this is not recommended. It is preferred to delay sign-in as long as possible. So this meant huge implications for the app. So what would an accountless user experience mean for our application? Well, essentially, it would mean that to allow the user to explore the neighborhoods catalog on Cornershop without actually registering some sort of address. So we could use some sort of general GPS detection to determine their approximate neighborhood. And it would also mean that we should add the ability to add items to local carts. So a user should be able to explore content stores and be able to add products without having to register an account until finally we need some information from them, which is at the checkout process. So the challenge of this, we want to launch this support as soon as possible because we saw data from other applications and other use cases that this would probably improve our user conversion rate significantly. It would also mean that the previous user and cart infrastructure was going to be very difficult to work with because it was our oldest and most convoluted code. For example, this didn't respect any of our traditional architectural approaches where we use MVVM or MVAP, for example. And in this case, we just had this giant not even MVC, it was just like a monster of singletons and views. So just to give you a little bit more context, the state of the legacy cart was very monstrous. So we have here the remote cart with all its responsibilities contained into this giant ObjC class. It interacted with Firebase as our remote database. It handled several types of service processes, and it was referenced via singletons, communicating with the corresponding views that had reference to this cart via notification center. And not many people were familiar with this class, of course, because we had, as you can see, over 4,000 lines. So if you were to think of our standard architectural practices, how would our cart, our legacy cart, actually look like? Well, we would have the remote cart, but we would have a lot more separation. So in this case, we're showing the 3 different modules that where we primarily use the cart, which would be the address view, the product view, and the checkout view. So instead of having just giant monstrous remote cart with all its different services, we would separate out the services that are critical to all functions of the cart and the services that only apply for these specific modules. So for example, if a user were to change address and we had to migrate the cart from one address to another, checking which products are still available in that address, that seems like a responsibility that should be owned by the address view. And same for the checkout. This checkout validation process that lived inside the remote cart didn't actually need to be there. It could be moved into this sort of checkout module. And then we would have the product to item service. So this would be essentially a service that helps us convert between what we call cart items inside the model of the cart and the actual products from our Cornershop backend. And then the service for syncing with Firebase. But instead, we had that giant class with all these things wrapped in one. So integration strategy. We wanted the remote and local carts to be interchangeable. This would make it easier to move a user from a local account to a remote account. But ripping up the current code was not an option, of course. It was just too many things going on, lots of connections, lots of interdependencies, and of course a very tight deadline. So we didn't have time to fight this sort of model service wrapped in one structure and the notification communication sort of style. But this didn't mean that we had to maintain all of the ceremony, all of the complexity of the existing carts in this sort of new implementation. So compromise. We decided to standardize most of the exposed properties and methods of the cart, but extract the actual service work. So what does this look like? So we have the local cart here. It still maintains the responsibility of being a sort of model for the views containing the items per branch. And it would still handle view notifications. We didn't have time to rip that aside. So we would at least separate out all the different service processes into their own service classes. And each one would handle a different responsibility. So next, how did we choose the persistence framework that we would use? Well, we needed something that was quick to implement and very scalable. We wanted something that was easily accessible as well for the devs. So we had a couple of options that we were looking at. We were looking at core data, of course, Realm, and GRDB. But core data for us had too much complexity in terms of accessibility and documentation, especially for our junior devs. It would be very difficult, especially given the timeline, to be able to onboard them onto this whole local cart project, and the learning curve was too much. For Realm, we had the issue of lightweightness, so it was a bit heavy and too much complexity for what we desired. And of course, it required sort of like financial connection with that. And then finally, we had GRDB. Which is essentially sort of like a framework that allows interfacing with a SQL database locally. And this seemed like the best option for us. It was very Swifty, and it was very constantly maintained. because it was open sourced. So the first step for us in order to maintain the interchangeability of the remote cart and the local cart, basically abstracting them as just the same sort of object for the rest of the app, was to abstract the cart, and this would be done, of course, via some protocol called cart, which contains all the main functions and the properties of both types of carts. Then we handled the model communication. So as I said, we had this cart item, which is a representation of each product in the cart. Here we have a basic understanding of what it is with the properties, this product store, who added this product to the cart, the quantity, and so on. And of course, this class was not directly compatible with GRDB's interface, so we created a sort of auxiliary extension to bridge this compatibility, which was called local cart. And all we had to do was extend the local cart item with the persistable record and fetchable record protocols of GRDB to be able to very almost automatically be able to persist and also fetch records from the database, the SQL database. So here, if we wanted to record something, we would simply extend the cart item with persistable record, implement the encode function, overriding it, of course, and then basically convert the cart item to a local cart item and then encoding it from there. Then we worked on the persistent service. So with these conformances in place, we could easily work with the SQL database now. And we did this via this service. So here's a basic implementation of it, but we had the functions in order to save and delete items. So we would basically take a cart item, take advantage of the conformances to automatically be able to just save it. And then same with deleting an item or deleting items for a specific store. Then we had to work on the reload service. So we were talking about this sort of like translation between products and items. This was the service that would be responsible for that. So every time a user would restart a session, since they don't have any sort of like backend to pull information from, it was all in SQL, right? So we had to, even though we had a state of the cart stored in the SQL, we didn't have it up to date with the latest information in the backend. Products could change, prices could change, they could even be removed from a store. So we need to take into account by reloading the products and their branches every time the user starts the app. So we did this via this reload service, which basically was just an extraction of what existed in the remote cart and putting it in its own service, thereby being able to reuse it not only use it for the local cart, but also for the remote cart. And then we have this sort of helper class. So we also mentioned that there was a checkout validation logic entailed within the remote cart. So this logic actually had no communication with some backend service. And it turns out a lot of our functions and processes inside the remote cart didn't have any interaction with backend either. So we saw this as an opportunity to be able to extract common logic between the remote cart and local cart and just throw them into this sort of helper class that we could then, again, use for both modes of the user experience, both local and remote. So this would include analytics, property mapping, checkout validation, price calculation, and of course, we had some old ways of decoding JSON where we moved back and forth between item representations and dictionary representations, so we put that in there as well. So after all these different steps, we finally reached a point where the local cart was just any other cart for the app. We kept the same functionality exposure, making the carts interchangeable, but separating out the core functions in order to make them more flexible and reusable. This also helped us with reducing our learning curve for new developers to be able to jump in easily, take a look at how things were implemented in the local side, and say, okay, if it's implemented like this, then it's probably very similar on the remote side, if it's not already sharing that functionality. And we cleaned up tons of like messiness in the code. So that we were able to achieve that sort of like architecture that we had planned at the beginning, only with slightly different names. So just some takeaways that we want to go over from these two examples that we talked about. First, API exposure. So it's good to make sure that you have an understanding of the implications of a new API when looking at how you're going to implement it, whether in a new feature or in an existing feature. So you want to see how that feature is exposed across the app to be able to see if you might need to expose the API as well. But you want to minimize that sort of layer travel of the API. And early determination of this exposure will make it easier to also calculate the amount of refactoring necessary to be able to communicate with the product teams about the plan for that. And speaking of which, refactor minimalism is another takeaway that we hope you take from this talk. Making a list of refactors that would make it easier to integrate these APIs is crucial at the beginning stages. You have to have some sort of cost to benefit ratio if you have a lot of things on that list in order to be able to negotiate with the product and business teams and be like, hey, we have these like 10 different things that would be nice, but probably like these top 4 are more necessary than just nice, because it would make it easier not only to maintain the feature, but maybe also extend it. And be ready to just figure out what a practical refactor entails. You want to probably choose something that kind of sparks joy in you, and not just something that doesn't have a lot of impact or a lot of necessity. And then another takeaway is, this is probably a little bit more controversial, but it's good to be ready to be comfortable to stretch beyond your defined layers as a team. Often it's the case that we have like this set structure for how we want to construct a module, the architecture. But sometimes it just makes sense, especially when you have to interact with other layers or interact with legacy code, to use a unique approach to interface between them. In JP's case, he used a builder class. In my case, I used interactors and the helper class. And it's good to collaborate with your team to see what you're comfortable with using and what makes sense. Because yeah, maybe sometimes it does make sense to have this sort of new interaction class, but then other times it's better to just fit this functionality into your typical presenter layer or service layer or whatever. But you also want to avoid superfluous fluff in your layers. You don't want to confuse future devs by adding so much different types of layers in your code. And finally, be prepared to have fun, but also experience some pain. There are always unexpected blocks, especially with dealing with new APIs and connecting them to legacy code. You want to negotiate some buffer time with the product team, of course. Usually it's recommended to do 20%. If you think you'll finish something in 10 weeks, probably communicate that you will need 12 or 13 weeks. And if issues do come up, the most important thing to do is to communicate as soon as possible. Maybe get together with your team, with your iOS team or your platform team, and brainstorm some possible paths forward really quickly, and then communicate those with the product team and say, hey, we figured out this framework has this limitation. Maybe we can't achieve this exact logic that you want or this exact design that you want. Well, we have these alternatives. Or maybe we'll just need to fall back to a slightly different approach. Just don't delay that communication so you don't dig yourself into a big hole. And yeah, that's it. Thanks, guys.
Thank you.
Hey, great talk. Thank you, JP and Ever.
Thanks.
So we have a bunch of questions for you. Hope you're prepared. Okay, so Fernando asked, do you have snapshot testing? So if yes, How does it go with this new SwiftUI feature?
Cool. Yeah, we have snapshot testing, and actually, I don't know if you, who asked? Fernando?
Fernando, yes.
Yeah, if you already heard of, there's a pod that is called, it was called FB snapshot testing, and now it's called iOS snapshot testing. It is managed by Uber. We don't use that one in Cornershop. We use the other one that is made from the competitor, that I'm not sure what's the name of. But yeah, SwiftUI works with snapshot testing. We have all those cards, states addressed in testing. The only thing that we needed to avoid was with some tests of the product detail view itself. So when we were creating, like using this builder to create this SwiftUI instance inside Objective-C, the test completely, it fails, like it doesn't work correctly. So in order to test the SwiftUI view, you need to test it separately. It doesn't work, or we had a lot of issues trying to make it work together. Yeah.
Okay, cool. How do you separate legacy from new code?
Yeah. So we talked a little bit about using, trying to isolate these new frameworks or new code using these unique layers. Maybe it makes sense to use an interactor to interact just with that framework in a legacy code service, for example. One good example for us was implementing diffable data source and compositional layout. So we had our home content catalog where we have all the navigation between the stores, and that was built like one of the first things that was built, right? So I'd used this like crazy data source that was thousands of lines, and it was difficult to migrate all that to use diffable data source. So what we did was basically create a diffable data source builder that kind of like worked with this, with that old data source to be able to convert back and forth and be able to update the UI as correspondingly. But yeah, I think it's always good to take advantage of layer separation and possibly use these sort of helper layers.
Okay. You said that legacy code has a series of singletons. What are your opinion about singleton? Is it really an ANI pattern nowadays?
Well, honestly, more and more I am seeing singletons coming back again in newer projects. But for my own personal case, we think that use of singletons is still a bad practice. Even though we use it in a lot of places because of the code written back in 2015, we have tried to minimize, using the user session singleton, for example, and instead any new feature that we build or anything that we refactor, we try to inject the user session instead. But sometimes it is beneficial, especially if you're working with some sort of shared management or service. There are a few places where I think that makes sense.
Okay. Is this updater approach a pattern that you are proposing or just a workaround on this particular issue?
It is a workaround on this particular issue. Yeah, I wish Apple had a more clear documentation on how an observable object class affects the behavior and performance of a SwiftUI view. And to be honest, this was the biggest issue. We couldn't find like how much logic, how much of the logic of the effects we could put in this observable object class in order for it not to break completely. So I think it's a valid workaround. Usually observable objects needs to be very clean, and this is a possibility. But when I created this, it was commented with a to-do saying, let's change it later.
Yeah, and to be fair, like this updater helper was like mostly because of how big and kind of crunchy our existing models were, and we didn't have time to refactor the model layer, of course. So it made sense to use this workaround instead because of the lack of support for that amount of data processing. within the model. And we ended up reusing this updater in a few other SwiftUI with legacy code connections.
Some Xcode versions shows error while compiling SwiftUI components preview with existing UIKit project. Do you recommend always use SwiftUI workspace and import it?
Yeah, I mean, in some cases it's super easy. Like if you need to do a feature like this one, like this multi-imager stuff, where it is completely separated from the rest of your app, and you could, for example, reuse it in different places. I definitely recommend you creating a new project and using SwiftUI there and taking advantage of live preview and all that stuff, because it really doesn't work in a big project, at least for now. And to be honest, I didn't have a lot of errors. It was just that it was super glitchy and slow, so we couldn't use it in a practical way. We were just like building to test.
Yeah, preview is really nice, but when it works.
Yeah, exactly.
Xcode things. Have you tried using Combine from both sides?
Yeah, we actually migrated our authentication layers to use Combine, and that was also a little tricky given the connection of authentication. And we have a lot of rules with that, especially when you link an account to your Uber account. So we have like 4 layers of authentication that we had to do, and but the nice thing is that Combine allowed the stream of all of those different layers of authentication to be a lot easier to understand, because before that we had I think 5 different classes that totaled to 10,000 lines of code that were handling that. So using Combine implementation and separating out the responsibilities to each layer of authentication made it down to less than 1,000 lines, which is crazy.
Nice.
Yeah.
No more questions. Thank you so much.
Cool.
Let's
Thanks,
give him
everyone.
an applause.